Hi, my name's Brian Barry, and I'm going to be going over my Scissor Jack project that I designed and modeled in SolidWorks. In total, there were 17 pieces, and there are a lot of little holes that I had to end up filing because there are pins that just would not fit through. If you look, there's also threads in here I had to file because the drive screw was too thick. I also ended up filing the drive screws. Here we're going to begin the assembly process. So as you see, I already have one arm assembled, but I'm going to show you how to do the other. So you put the two lifting arms together, and then you put this space saver between them. There's one that's threaded and one that's not threaded, and then to do this you put the pins through the side and they actually lock that space saver in place, connecting the two arms. Because the fitment is so tight, I was having a little bit of trouble trying to get them to fully lock into place, so I ended up tapping them with the butt as a screwdriver, as you'll see here shortly. This is completely okay. It doesn't really affect it, but make sure you don't hit it too hard because it is only PLA and it is fragile. After you have the arms both assembled, you'll notice that one side of the arms have a wider diameter. This side ends up going into the bottom foot. Here I have two sets of pins, one's longer than the other. You need to use the longer ones for the bottom because the diameter is so much thicker. Once you have the one arm completely in, then you need to align your teeth so that your holes line up appropriately and you're able to get that other pin in. Once you have your arms locked into that bottom base plate, now you can align the top gears and connect them to your top carrier plate. Now your gear teeth also have to be aligned for this, and you're going to use the shorter of the pins. Now for the final step, you want to make sure that both your holes are aligned so you can put your drive screw through. You're going to feed it through the non-threaded end first, that way you can thread it into the second hole, and that will allow the jack to raise and lower. The jack is about 14 inches wide and a little under 4 inches tall when lowered. Now to raise it up, you can put any kind of little metal rod or anything and just twist it or twist it with your fingers, both work. But as you see, the jack does raise and it also does lower, as you'll see here shortly. Here I raised it up to about 12.5 inches tall to keep the stability, and as you can see, it does need some weight on the top to lower back down correctly. This is completely optimal for using it under a car or anything like that. However, this is just a model. To make that one, you should probably use something a little more sturdy than this PLA that I ended up using. This is my Scissor Jack, and I hope you enjoyed.